Model training is a critical phase in the machine learning lifecycle. It involves feeding data into an algorithm to help it learn patterns and make predictions. This process is iterative and requires careful tuning of parameters to achieve optimal performance. In the DP100 course, running model training scripts is a key skill that prepares you for deploying models in real-world scenarios. Training scripts are essentially programs written to automate the process of training machine learning models. These scripts can be written in various programming languages, with Python being the most popular due to its extensive libraries and frameworks like TensorFlow, PyTorch, and scikit-learn. A well-written training script ensures reproducibility and efficiency in the model training process. Before running a training script, it's crucial to set up the environment. This includes installing necessary libraries, setting up virtual environments, and ensuring that the hardware, like GPUs, is configured correctly. Tools like Anaconda and Docker can help manage dependencies and create isolated environments for different projects. Data preparation is a foundational step before running any training script. This involves cleaning the data, handling missing values, and performing feature engineering. Proper data preparation ensures that the model receives high-quality input, which is essential for accurate predictions. Techniques like normalization, scaling, and encoding categorical variables are commonly used. Selecting the appropriate algorithm is crucial for the success of your model. Different algorithms have different strengths and are suited for various types of data and problems. For instance, decision trees are great for interpretability, while neural networks excel in handling complex patterns. Understanding the problem domain and the nature of your data helps in making this choice. Hyperparameters are settings that you can adjust to optimize the performance of your model. These include learning rate, batch size, and the number of layers in a neural network. Hyperparameter tuning involves systematically searching for the best combination of these settings. Techniques like grid search, random search, and Bayesian optimization are commonly used for this purpose. Once the environment is set up, data is prepared, and hyperparameters are tuned, you can proceed to train the model. This involves running the training script, which will iterate over the data multiple times epochs to learn the underlying patterns. Monitoring tools like TensorBoard can help visualize the training process and track metrics like loss and accuracy. Overfitting occurs when a model performs well on training data but poorly on unseen data. This is a common challenge in model training. Techniques like cross-validation, regularization, and dropout can help mitigate overfitting. It's essential to monitor the model's performance on a validation set to ensure it generalizes well to new data. After training, it's crucial to evaluate the model's performance using various metrics. Common metrics include accuracy, precision, recall, an F1 score for classification tasks, and mean squared error, or R-squared, for regression tasks. Evaluating the model on a separate test set helps ensure that it performs well on unseen data. Once the model is trained and evaluated, the next step is to save and export it for deployment. This involves serializing the model into a format that can be easily loaded later. Frameworks like TensorFlow and PyTorch provide utilities for saving models. It's also important to save the pre-processing steps to ensure consistency during deployment. Automation is key to scaling machine learning workflows. Tools like MLflow, Kubeflow, and Azure Machine Learning can help automate the training process. These tools provide features for tracking experiments, managing models, and orchestrating workflows. Automation ensures that the training process is reproducible and can be easily scaled to handle larger datasets and more complex models. Model training doesn't end once the model is deployed. Continuous monitoring is essential to ensure that the model performs well in production. This involves tracking metrics, detecting data drift, and retraining the model as needed. Tools like Azure Monitor and Prometheus can help in setting up monitoring pipelines. Regular maintenance ensures that the model remains accurate and reliable over time. Running model training scripts is a multifaceted process that involves careful planning and execution. From setting up the environment to monitoring the deployed model, each step is crucial for the success of your machine learning project. Following best practices, such as proper data preparation, hyperparameter tuning, and continuous monitoring can significantly enhance the performance and reliability of your models.